Good. Now, let us have another discussion in our done series of statistics about the measure of central tendency. Previously, we discussed about mean, and we saw that mean, how to calculate mean in ungrouped data, in ungrouped data. Another measure of central tendency is what is called median, which means the center, which means the central, which means the left equal numbers of subject are there, left side of the subject equal numbers are there. So this is the centrally located subject of study in this collection of data or in a population. Now, today we are going to discuss on how to arrive at this median or this calculation of called median, which is a measure of central tendency again, and we will see it in either grouped data and also in an ungrouped data, and also you'll see it when the observations are even or if the observations are odd in a population. In this case now, the key important thing when you're doing a median calculation, you should arrange your data or a subject of study or your observations in ascending or descending order, so that you can be able to calculate that data well. Now, there are two. At this point, you are going to start with the calculation of mean using the two formulas. That is, I mean, if the total number of data or subject of study is odd, and when the total number of study is even. So the formula of calculating a mean when the total number of a subject of study is odd number is you get the total number, you want plus 1, then you divide by 2. You divide by 2. This is what I mean. Total number plus 1. Then all these we divide by 2. Multiple there. The net number, that is the net number. Let's see in even number, you have realized that the number of study is number 12. So you add plus 1, then you divide by 2. That is how you get the median number. In another way, also in a group data, you get it as the point, the 90 number divided by a half if it is even number, plus the n number plus 1. Then if that is even, the number is the even number. That is, it is an even number. Then you divide by 2. For example, that is we have a data of number 10. So you see the 10, the median is the 5th divided by 2 plus you get the number at that point. Now, let us look an example of whatever we have just discussed there. Calculate the median for the following series. For example, you have 2, 3, 5, 1, 4, 5, 8. This series. The key thing here is that you should put this number in ascending order. The first step, yes, put either as I said, ascending order or descending order. By doing what? You start by saying you put 1, 2, 3, 4, 5, 5, 8. You see our number are 1, 2, 3, 4, 5, 6, 7. There are 7 of them. There are 7, and 5 is appearing twice. You can see it, 5 is appearing twice. So in this case, you are arranged your data in ascending order from the lowest to the highest. That is the first step when you are doing a calculation of mean. So the median is the number of solutions, the number of observations plus 1 divided by 2. In this case, n is 7, and 7 is 1, 2, 3. That is 1, 2, 3, 4, 5, 6, 7. So all of these ones are 7 observations, and they are represented by this number n there. Then you add plus 1, which is getting a plus 1. Then you use the body mass, so you'll see that 8 plus 1, 7 plus 1 is 8 divided by 2. So the median number is the fourth number. That is 8 plus this is divided by 2 is fourth number. So in this case, our fourth number is what? You come up there again, you see our fourth number is 1, 2, 3, 4. So our mean is around this area. Our median is around this fourth number. You can see fourth number, you can see 1, 2, 3 on this side. You can see 1, 2, 3 on this side. So this is our median. This is our median. And let me repeat ourselves again. Let us repeat this calculation again so that we can understand it well. You are given a data. The key thing is that you arrange this data from ascending order to the descending order, or the other way around. That is how you do that mathematics. Now, in this case, you arrange this data from the lowest to the highest, and the lowest is 1, followed by 2, followed by 3, followed by 4. 5 is appearing twice, that is this 5 and this 5, then 8. So all of them, there are 1, 2, 3, 4, 5, 6, 7. So this is a series of 8 data. So when you have to calculate the mean, you see the total are 7 plus 1 divided by 2. So that you get what? Fourth. And the fourth number is what is absorbed. So you come here and see that in this case, the fourth is 1, 2, 3, 1, 2, 3. So this is the point where the observation is. That is observation. Now that is good. Let us look now another. Let us look now at another type of calculation. In this one, the data on pass rate per minute for 10 patients are as follows. One patient and 82, the other patient and 79, the other patient and 60, the other patient and 76, the other patient and 63, the other patient and 81, the other patient and 68, the other patient and 74, and the other patient and 60, the other patient and 75. Now, in this calculation, what is our total? The total is 10. You can see that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our n is 10. In this case, this is an even number. So in this case, in this 10, we know that in this 10 now you have to be very careful because they are the 10, if you divide it, is 5 on this side, 5 on the other side. So if you arrange this data in ascending order, we get 60, 60, 63, 68, 74, 75, 76, 79, 81, 82. Our data is in ascending order. So our middle number is either in between 74 and 75. Meaning what? We have 1, 2, 3, 4 on this side, 1, 2, 3, 4 on the other side. So in between here, this is our median where it is located. Our median is in between 74 and 75 but we don't know it. We don't know it, it is there, and we have to look for it there because this one is on the 4, 4. So this is the middle. This is our middle. So in this case now, out to line so that you can have a proper calculation. We say that 74. We say that the end number that is 74. 74 divided by 2 plus 75. The formula is 75 divided by 2 plus 1 plus 1. So this is the number. So we say that 74 plus 75, it gives us 74.5 as the median. So we say that 74 plus 75 divided by 2 is divided by getting 74. So in this case, our median is 74, 74 and divided by 5 is our median. 74 divided by 5 is our median in the case that's 74, and then 75 then divided by 2. Here you have seen this is the formula. 74, that's the formula. Now we can find out the median for number of small things that is happening in an input. You can see that 7, 57, 65, 46, 12, 14, 19, 23, 56, 78, 53, 33. So in this case, you have to arrange this data either in ascending or descending order. Okay, either ascending or descending order. In this case, so you will get this number. So in this case, you have to arrange this one with number. Then if you look at the middle, you see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12. So that means 6, 7. It's where it is. So after you enter this data, in ascending order, you get 67. That is where the number will be. In this case now, if you have one like that, if you have this one like that, you get 10. So you can read this one and get the 7 and the 6 will be our number. So let us look calculation of a data. A median in a grouped data. The median in a grouped data, you have the formula where error stands for the row limit of class interval where the median occurs. So in this case, first of all, you should put this data in a classification. You see them later on. So that is where the median occurs plus frequency before. So 3 fingers of that class. Then you have the length of the median class. Then you have cumulative fingers of the class preceding the median class. Now, let us see this one in a very simple mathematics. You have seen that this one is representing the low limit class interval, the total divided by 2 plus the class frequency, the interval of the class, then times frequency, and then the mean of the class. Now, let us have this data here. You can see that the key thing here is that the data is already classified. For example, the window of the class is 0.5, that is from 2.0 to 2.5 is 0.5. That is the window of the class. In this class, the lowest limit is 2, the highest limit is 2.5, and the frequency is at 7. In the next class, the low limit is 2.5, and the higher limit is 3.0, and the frequency is 117. Then you continue like that. You have arranged your data like that one. Very important. Then from there now, you come to the next step where you add the cumulative frequency. In this case, we have a class of the lowest limit is 2.0, the highest limit is 2.5, sorry. The lowest limit in this class is 2.5, the higher limit is 3.0. The number of frequency is this. Then you add the cumulative. In this case, what does the cumulative frequency happens here is that you see this one plus this class will be this 154. Then in this class, you get the cumulative in the previous class plus this class. It gives the cumulative in this class. Like that one, until you get the total cumulative of 590. Of 590. Now, in this case now, is that you want to know what is the median. So the median class is 3.0. So in this case now, where is our median is median is what? Our median is in this class is somewhere here. But it's 590. So when you find it, you see that 595 is our median. So in this class, the class median is 3.0. So this is the class. So the raw limit is 3.0 and the frequency is 2.7 and the cumulative frequency is 154 and the length of the class is 0.5. And we are talking about this class. The class we are talking about. It is the class which is giving us these parameters. So out of that one now, you make your calculations using this formula. This is the low limit of the class, the length of class, the cumulative, the frequency, the number. So here you see that the low is 0.5, the low limit. Then you get the frequency is 2.7, and then the total is 2.5. When by this one you get that answer, then you multiply by 0.5, then it gives you this one, it gives you 3.5 plus this times 0.5, when by this one you get 3.4. Then you add this one, you get 3.4. So the median weight is 3.4 in that calculation this class. So we have used these parameters in this class. In this class, let us get that calculation. Now, let us see data. Another calculation. Of the same nature. From grouped data, calculate the median for the following data. You can see the class interval is 5 to 9. So you can see the lowest limit and the highest limit. You can see the frequency. Then so you can bring it from this cumulative. This one is the cumulative data. And then we come to our formula. The total number of observation is 76. The low limit of the class interval is 15. And the range of the median class is 4. Where have we got this from? This is 76. 76 divided by 2 is 34. So in this case, you come and look where that 4 is. 34 is somewhere here. 34, you have arrived from 34 by dividing this one into 2. 76 by 2. So in this class, the low limit is 15. The range of the class is 4, and the frequency is 26. The cumulative frequency of the class proceeding the media is 13. Now that's our formula. Low limit plus total number divided by 2, which is 34, minus cumulative frequency of the proceeding median times the length of the class divided by the frequency. So divided by the frequency, and that is how you get this median of that class. So basically, that is the most important way of doing a median. So do that is so that you can be able to understand it better. Thank you very much for listening to this class. The next unit will be about mode. That is the most common.